Hi guys, welcome back. We're going to continue talking about probability in 10.3, day 2, I believe. So what is theoretical probability? So go ahead and pause that and kind of come up with a definition, looking back at your notes if you need to. So theoretical probability is what is going to happen in theory, okay? So when I roll a die, in theory, I will get a 3 1 out of 6 chances. But I know when I do experimental probability and I actually roll a die 20 times, I might not even see a 3 at all in those, right? Because it's random. So theoretical probability is what should happen. Experimental probability is what is going to actually happen in a setting if we roll a die so many times. And that could change with each experiment. So the theoretical probability will happen probably eventually. If we rolled a die 1,000,000 times, we'd probably get pretty darn close to the theoretical probability, if not perfectly. Okay, so we're going to continue talking about relative frequencies as probabilities, okay? Again, that's like your experimental probability. So we've spun a spinner 200 times and record the letter it lands on. So maybe we have a little spinner and it's separated into 5 categories, right? And I'll draw these as even as possible. And we have an A, B, C, D, E on there, okay? So we spun it and recorded how many times we got A, B, C, D, E, and E. D and E, okay? So for letter A, we got 36, letter B, we got 44, letter C, we got 28, letter D, we got 52, and letter E, we got 40. So in order to find the relative frequency, I need to know the total number of each of these all together. So we're going to have 36 plus 44 plus 28 plus 52 plus 40. Gives me a total of 200, which is good because at the top of my problem here, they told me there was 200 times, so I didn't even really have to add that up. But it was good to double check. So the relative frequency, remember, is just our observed number divided by our total number. So 36 divided by 200. And it doesn't tell me how to put this, so I'm going to put it in percentages just for giggles. So 36 divided by 200 would be 18%. 44 divided by 200 would be 22%. 28 divided by 200 is going to be 14%. 52 divided by 200 is going to be 26%. And 40 divided by 200 is going to be 20%. Now again, I can add all of these up to make sure they're going to be 100. So 18 plus 22 plus 14 plus 26 plus 20 does in fact add up to 100%, so I can check myself off. I know I did well on that. Okay, so part B, it says if you were to spin the spinner again, which letter would you predict to come up? Well, I'm going to look at the highest probability of something occurring. The highest percentage right now is D. That seems to be appearing more often, okay? So I would guess letter D, okay? Now, A, B, C, and E all have an equal chance of appearing as well, but because I'm observing something happening, I'm going to say, well, I'm going to go with D because I seem to be landing on that. So maybe our spinner isn't as random as we thought it was. Maybe it's a little weighted. Or maybe just we're appearing with D's and maybe our next one will be C and we just don't know that. Okay? But we can take a legitimate guess and see what our best option will be. Okay? So we're going to do the same thing. So it says comparing long-run relative frequencies and theoretical probabilities. So we took a die and we rolled it a bunch of times. So this is how many times we got each number. And again, we're going to total up how many we have so we can find the relative frequency. So 32 plus 35 plus 40 plus 30 plus 33 plus another 30 would be another 200. So we have a nice 200 number here again. So we had it rolled 200 times, okay? So to find the relative frequency, we're going to do 32 divided by 200. And again, I'm just going to put these in percentages just for ease, which would be 16%. We could leave it as fractions, but it's nice to look at percentages just because then you're comparing in the same way. 35 divided by 200 would be 17.5%. 40 divided by 200 is going to give us our nice 20%. We're going to have 30 divided by 200, which is going to give us our nice 15%. And I'm seeing that's the same down here, so I'm just going to hop here. So I don't have to think too much. And then 33 divided by 200 equals 16.5%. Okay, and if I were to add all those up, I would get 100%, which would is perfect. So I can see here I'm getting these percentages for each number appearing when I roll a die. But theoretically, we know each one should happen 1 out of 6 times, which when I do 1 divided by 6, I'm going to get 16.6 repeating percent. And that would be true all the way through for every number, because in theory, they should all appear the same amount of times. Now, if we kind of just compare some of this data a little bit, some of them are very, very close, right? Particularly on number 1 here. Oh, I didn't draw my little repeating sign, sorry. Okay. Particularly on number 1, it's very, very close, and number 5 here. Okay. We went a little bit over on 2, 3, and just on 2 and 3 went over, and we went a little under on 4 and 6 here. Okay. So just to kind of show you that the relative or the experimental probability can be different than the theoretical probability. One, we didn't roll as many times as we could have. If we kept rolling, we might have seen that percentage change a little bit. But that's okay, that the relative and the theoretical are different. Okay, that's what happens. So this is more real life. This is what should happen in theory. Okay. So here's your exit slip. So go ahead and pause the video and read this and see what you can come up with and come back and check your answers. So Wyatt made a dartboard with the outside ring being blue, the middle ring being yellow, and the bullseye being red. He threw a dart at the board 100 times. Find the relative frequency of each color. Okay, so we did this 100 times, so I know my total is 100. So we're going to do 10 out of 100. And 35 out of 100. 48 out of 100. And 7 out of 100. Now you could leave this as a fraction if you'd like, or you can find your percentage. Again, I like to find my percentage just because it's easier to kind of see what's happening. So 10 divided by 100 would be 10%. 35 divided by 100 would be 35%. 48 divided by 100 would be 48%. And 7 divided by 100 would be 7%. And again, if we added all those up, they would add up to 100%. So you're probably going to miss 7% of the time. The chance of you getting a bullseye is only a little bit higher with 10%. More than likely, you're going to hit that outside ring with a 48% chance. Hope this finds